Hi and welcome to the video. Today we're going to look at RegEx, which is short for regular expressions. This is essentially the de facto standard for parsing text. So what we're going to do in this video is run through the basics of RegEx first. So stuff like how to define digits, white space, how to use quantifiers to tell us how many digits or white space or any other character we want to include, how to use capture groups and character classes, and also how we can use boundary definitions, so how we define the start of a line, the end of a line, or boundaries of a word. And we should move through these quite quickly because they're not very difficult. They're pretty straightforward. And then we can move on to what I think is the more exciting, interesting stuff, which is a little more advanced. So these are things like look ahead or look behind assertions, modifiers, and conditionals, which are essentially like if-else statements, but for your RegEx code, which is pretty interesting. So we're going to work through all of that in this video. We're going to code through a few examples in Python. We're also going to use RegEx 101, which is like an interactive debugger or RegEx building tool that we can use. So it should be pretty interesting. And let's jump straight into it. Okay, so we're going to start in RegEx 101 and we're just going to have a look through a few of the metacharacters. So let's say we have this string. I'm just going to make it up. We have a few letters in here, some numbers, and two other characters as well. Now, we can obviously directly match these by actually writing out the exact characters, but generally we're not going to want to do that if we're using RegEx. So this is where we start to use metacharacters. So we'll just go through the most common ones. We have digits. This will match any number, so anything between 0 and 9, and we can inverse that with a uppercase D, and then that will match anything that is not a digit. We have W, which will match any word character. And then we can also reverse that again by capitalizing it. So all of these meta characters, we can usually uppercase them and it will reverse what they're doing. Do white space with S. In this case, we don't actually have any white space, so let's add some in. And it will also match new lines as well. So you can't see this highlighted, but if you look up here, you can say 2 matches. Then if I add that new line in, it goes up to 3. Then we'll do anything but white space. We just uppercase that again. And then this one's a little bit of a special one. This one matches any character except from new lines. So this is not matching our new line here. We obviously can't uppercase this one, but I suppose the opposite would actually just be a new line character like this. So let's switch over to Python and see how we would do this. So we import re, which is the RegEx module. And we'll go through these a little bit in more depth later, but for now, we're just going to do re.findall. And in our first argument here, we put the pattern that we are going to use to search. So in this case, it would be \n. Although we're not going to use that, we're going to use \d for any digits. And then let's just pull this one in. Okay, and we return 1, 0, 0, 0. Okay, so these 4 characters here, which is exactly what we would get here. Okay, so that's cool. Now, in the case of this full stop, what if we would like to actually match a full stop and just a full stop? To do that, we actually escape the meta character using a \, and just like that. Okay, so that's it for meta characters. Let's move on to quantifiers. So quantifiers essentially allow us to match a specific number of characters. So as of yet, we've only been matching 1 at a time. So here we are matching 4 characters, but we're only matching 1 character at a time, 4 times 1, 2, 3, 4. Whereas quantifiers allow us to write our pattern and then add this quantifier to specify how many times to actually match that. So the first of those is the 1 or more quantifier. So this will match that pattern 1 or more times. It's just a plus sign. We also have 0 or more quantifier. So this is matching that pattern 0 times or more times. Okay. And something that we can also add in here, as you'll see, this is matching it as many times as possible, but maybe we actually want to limit the number of times I'm matching something. And this is the difference between what is called greedy and lazy quantifiers. So at the moment we have a greedy quantifier. So it's saying 1 or more times, and it's going all the way up to 4, okay, which is as many characters as it can fit into its pattern. But if we want it to not do that and instead be lazy and simply pick up as few characters as possible that match the criteria, we can just add a question mark onto the end. And then we're back to matching just 1 because it's 1 or more, and we are limiting it to the minimum number of matches there. So keep that in mind, and we'll just quickly go over it again towards the end of this a little bit. We also have the once or none. So let's write a new test string here. So here we have a few words, and we'd like to match all of the words. So what we can do is this. And here we're kind of matching all the words, but there's this one in the middle where we have a hyphen in the middle. And this is something that will happen quite often. And ideally, we also want to put good-hearted as a single word. So we could do this. But then we're only matching that single good-hearted part. So instead, we add a once or none quantifier. Okay, so now we're matching that word as well. Now, if we also want to match the A, because you can see here it's not matching because we're expecting at least 2 word characters because we have W here and W here, we can just add a 0 or none quantifier onto the end there. And now we're getting all of our words together, including the hyphenated words. We can also specify a specific quantity, which we do like this. So here we are getting 3 word characters at a time. You can see here we're not specifying 3 characters that make up a word, we're just saying 3 characters. So here we're getting multiple matches for single words, which is fine because we haven't specified that. We'll go over how to define word boundaries later. And we can also turn this into a range. So let's go 3 to 5. Okay, so now we're matching at a minimum 3 characters and a maximum 5. Now you might have guessed this, but we can actually just remove one of these numbers to get less than 5. Now if this doesn't work for you, just make sure that you are using the Python flavor, because for other languages this might change, and if you're on PCRE, for example, this won't work. So change back to Python. And we can also do 3 or more as well. Now, I think this is a good example with our lazy quantifier. So here we're matching between either 3 up to 5 characters at a time. If we had a lazy quantifier, it's always going to limit that as much as possible. So we're going to go down to 3. Okay, so you can see here that it's limiting how many characters it's including in there. It's getting lazy rather than greedy. Okay, so let's write out a new example here. Okay, so a few unexpected words are to be expected. So this is a good example of where we can use capture groups. So anything contained within round brackets we'll create a capture group. So a capture group is simply a fancy way of saying treat everything within these brackets as a single unit. So you can see here, I only put these dots in as a filler, but it actually matches because those dots mean anything. So 3 anythings in a row, and this is matching, basically anything. So we have all of these matches here, and it's treating those as a unit. So it's doing 3 anythings and matching that, and then moving on to the next 3 anythings. Now, what we can do is we want to match unexpected and expected. So we want to match the word with or without its negative prefix. So we can add expected here. But here we're only getting expected. We're not getting the un from unexpected. So we just add this. So now we're getting unexpected, but we're not getting expected because we have specified, okay, we want UN here. We want this capture group. So all we need to do is actually make this optional by adding a 0 or 1 quantifier. And there we go. We are now capturing unexpected and expected. So let's have a quick go at this in Python and see what it looks like. Okay, and we run this. And now we find that we are only seeing un, which is probably not what we're expecting. The reason this happens is that findall tries to match capture groups, which is exactly what we have here. So what we can do is modify this capture group to make it a non-capturing group while still maintaining this behavior of 0 or 1. So all we do to do that is add a question mark inside, followed by a colon. And then here we are capturing everything again. So that's just a little bit of a strange behavior to watch out for. Now, we can also add a OR logic to our capture groups. So maybe we want to capture anything where we are saying expected with a negative prefix, and that can either be not expected or unexpected. And we want both of these to match. Now, to do this, we actually just add a pipe into our capturing group. And then we add not, like so. And now we are matching both non-expected and unexpected. Okay, so that's it for capture groups. And let's move on to character sets. So the syntax for character sets is kind of similar to the syntax for capture groups, in that we use brackets, but this time they're square brackets instead. And you can see these kind of like a list. So anything we put within here will be treated as a character to match. But unlike capture groups, it's not treating them all as a unit. So if we put un in here, it's actually just matching either U or N. And we could put unexpected, and it's not going to match unexpected as a unit. It's just going to match each one of those words within those square brackets. So let's return to our earlier example. So earlier on, we were matching all of the digits in our string. So what we could do is write out all of the digits like this, and we get the exact same effect. Obviously, this is quite long, so what we can do instead is write this with a dash in the middle, and this is any character within the range of 0 to 9. We can also add letters to this, so A to Z, for example. And you might also think, okay, we can also add these hyphens in, right? But obviously we are using these hyphens to define our ranges. So in order to add a hyphen in here, we need to use backspace to escape it. And now we are matching the full string. And if we want to match full string as a whole, of course, we just add our quantifier. Now let's move on to boundaries. So I'm just going to write out a new string for this. Okay, so here I want to show you the start string and end of string boundaries. So the start string is using this character. So here if we put if it, it's only going to match if it at the start here. It's not going to match if it here as well. And if we remove the character, it does. Okay, so we add this character to specify that we only want to search from the start, very start of our string. Now, the equal and opposite of the start string character is the end of string character, and that is a dollar symbol. So let's rewrite this. Okay, and we want to look for example. And here with the dollar symbol, we only match the final example rather than both of them, as you can see there. I'm going to go back to one of the earlier examples again now. Okay, so here I also want to show you the word boundary. So the best way to identify word boundary is not by using, for example, white space, because yes, that does work in a lot of cases, but it doesn't work if we have a comma, full stop, a hyphen, or anything like this. So what we can do instead is use \b. And this identifies every single word boundary within our text, as you can see from the pink lines. So then we can use that to capture any of our words. And now quite easily we've captured every single word and we're pulling them out in a more efficient way than if we had tried to write S, or if we'd have gone with a grouping like this and added all of these different things. All we need to do is add a word boundary. Okay, so now we'll move on to some of the what I think are the more interesting and definitely a bit more advanced methods in RegEx. So the first of those is the look ahead and look behind assertions. So if we have this string here, we have two hello worlds. One of them is preceded by a 1 and a colon, the other preceded by 2 and a colon. Now, what if we want to match hello world, but we only want to match hello world if it is preceded by a 1 and a colon. But we don't want to include that 1 and a colon within our pattern, because if we want to do that, we would just write this. But this will return the entire string. So I'll show you over here. Okay, so we're returning the full string. What if we only actually want to pull out this hello world? Well, we could go for hello world, but then we're returning both. We don't want to do that. We only want the first one. So to do this, we use a look behind assertion. So this means that we are looking behind our pattern, which means anything preceding it, and we are asserting that there is this other pattern there. So we do this with this pattern here. Okay, and anything we place in between this equal sign and this closing bracket is included within our assertion pattern. Okay, so now we are matching just this first hello world. So if we go and take this and put it into our code here, we will return just the first hello world. Now, on the other hand, maybe we want to match something that comes after our pattern. And to do that, we use a look ahead assertion, which, as you've probably guessed, is basically exactly the same, but on the other side. It does use a slightly different syntax, but other than that, there's really no different. So in our case, we're going to search for this comma. So in between the equal sign and the closing bracket here, that's where we put our pattern. And here, again, we're matching this hello world. And we can put this in Python, and of course, we'll just get the exact same thing. Now, on the other hand, maybe we don't want to assert that something is in front or behind our pattern. We actually want to assert that something is not there. So what we can do is we can make this a negative look ahead by replacing this equal sign with an exclamation mark. And now we are looking for the hello world that is not followed by a comma, which is obviously this one. And again, with the look behind, we just modify that as well. So whereas the look behind looked like this, we just again remove the equal sign and replace it with a exclamation mark. And then we get the second hello world. Okay, so that's it for the assertions. Let's move on to modifiers. So we can actually see we have a few modifiers here. And these are essentially ways of modifying the behavior of our entire regular expression. Now, obviously Python doesn't have this little set regex options here. So what we do instead is we can either do an inline modifier like this one. And let me just give you a good example quickly. So we'll just write out a string that includes a new line character in the middle. Okay, and we're going to match character and then anything following that character. Now, if you remember, this anything metacharacter does not actually match anything. It matches anything except from new lines. So in this case, it is not matching here because we are expecting new line. Now, if we open this, we can see that we have this single line. Dot matches new line. So we add that, and now it's changed the behavior of our regex, and the anything meta character also matches new line characters. Now let's remove it from here, and we can add it inline like this. So here we're just adding the S within this global modifying function. And we can also add other modifiers as well if you want. So all you need to do is add the letter that represents that global modifier and add it within those brackets. Now, if we take that over to Python, and we add this in. So here is our inline modifier. Yep, it works. That's great. If we get rid of this, it doesn't match anymore. And that's what we would expect. Now in Python, we can also add modifiers within the function itself. So what we do is we add re dot and then the capital of the modifying flag. And there we go, it matches again. So there's a few different ways that you can do it in Python. Now let's move over to conditionals. This is the last one we're going to work through. And these are probably a little more complex in my opinion to actually read and understand. So I'm going to use a few different examples here. I'm just going to quickly make this up. Okay, so we have these 3 lines. Each of them has something in common. Now, what I want to do is enter a condition within a capture group, which is either true or not. Now, I don't really want to specify that I need this condition within my regex, because if it isn't there, I want to search for something else. And to do that, we add this group here, and this is basically our if-else group. So I'm just going to put I here for now. I'll explain that in a moment. And this is our, if the condition is true, then we also want to search for this. If the condition is not true, then just search for this instead. So our condition here is within a capturing group. And this token here refers to the index of our capture group. So in our case, we only have one capture group, And you can see here it even highlights first capturing group. So this actually needs to be 1, and then that essentially links our condition within this capturing group to this if-else statement. And we can see that now, okay, this condition is not true because we haven't written condition anywhere. So it's going into the if clause and it's saying, okay, if it's true, which it isn't, search for this, right? But it isn't true. So we are actually only searching for by. So it is producing a match because all we need to match to is by. But in reality, we actually do want to search for a condition, which is going to be hello. And here now we are matching 2 things. We're matching this because hello is true here. And if hello is true, our if else statement says, okay, now we need to match space world, which we do right here. And on this line, just like before, we're finding, okay, hello is not true. It doesn't say hello here. So this is not what we want to look for. We actually want to look for this, which is our else statement. And we do, in fact, have by here. So that, again, does match. So, I mean, that's everything on the regular expressions. And I just want to quickly go through what the difference is between re.match, search, and findall in Python. So let's remove these. So I'm just going to write a string very quickly. Okay, we're just going to use this as our example. Now, if we do re.match, you remember before we had this starter string character. re.match essentially is like putting this character in front of whatever you type within it. So what I mean by that is if we do re.match hello, we will get a match. So we also, as well, we need to put dot group after we use re.match or re.search, something to be aware of. Okay, and yeah, okay, fine. We would expect that because we're searching through and yep, there's a hello here, there's a hello here. Of course, it's going to match a hello, that's fine. But if we put world, we don't match anything. Okay, so it's a non-type, which means nothing has been matched. And the reason for that is that match automatically adds the starter string token in there. So if we put world at the start here, this would work. Okay, but obviously before we didn't have it there, so it didn't work. So that's what re.match does. It also just returns you 1 match. Unlike findall, you remember we were getting a list of matches. Now, re.search doesn't specify that we only need to look at the first part of the string. Instead, re.search looks through the whole thing. So if we search for world, we actually do get a response because we're not specifying it needs to be here. Okay, so that's great. But you'll also notice that we are only returning 1 thing here. And that will not change if we add hello. Okay, we're still just returning 1 item. So what re.search does is it comes through here, it searches the whole string, but it only searches for the first instance. So it gets to here, it says, okay, I found hello, and then it returns that match. It doesn't go any further and finds anything else. And that's where findall is a little bit different. So findall, we can't use group here, we just print out X, does go through and find everything. So that's it for this video. I hope it's been useful. We've been through a lot of RegEx, so don't worry if it kind of blew your mind a bit if you're new to this. It is quite a lot. But nonetheless, RegEx is super important. I would definitely recommend getting familiar with it if this is new to you. It's an incredibly useful skill no matter what you are specializing in. As long as you code, you're probably going to use RegEx. So that's the video on RegEx. I hope you enjoyed. And as always, thank you for watching. Bye.